Hey guys, it's Mrs. Stewart. This lesson is on graphing functions. We're going to focus on how to graph a function with a defined domain and with no defined domain. First of all, I want to take a look at equations written in function form. You'll see these written f of x instead of y, but they actually mean the same thing. Okay, so f of x equals x plus 3 means the same thing as y equals x plus 3. F of x equals 2x plus 1 means the same thing as y equals 2x plus 1. It's just the f of x can be replaced with y at any time. Now what we'll do is start with graphing a function given a defined domain. Here's an example. So I have a function, f of x equals negative 2x plus 4, and I'm given a domain to use 2, 3, 4, and 5. So those are the exact x values that I will use. Now, f of x is y, so you can replace it with y, and you can make it look like this. Y equals negative 2x plus 4. Now, we've practiced this in the last lesson. You can create a table of values, and I'm using the domain 2, 3, 4, and 5. So when you put the 2 in for x, you're going to get negative 2 times 2 plus 4, and that would give you 0. So when x is 2, y is 0. When I put in 3 for x, I get negative 6 plus 4, and that's negative 2. When I use 4 for x, I get negative 4. When I use 5 for x, I get negative 6. So I have exactly 4 points to graph. So I'm going to take these and plot them. The first one is 2, 0, so you can see we moved over 2 to the right and up nothing. 3, negative 2 means go 3 to the right and down 2. 4, negative 4 means go 4 to the right, and negative 4 means go down 4. 5, negative 6 means go 5 to the right, and then down 6. And that's it. You plot those 4 points and you're done. Notice that the range for this function is exactly those 4 y values. 0, negative 2, negative 4, and negative 6. Now, if you're not given a defined domain, we can choose our own. So you can see f of x equals x plus 3. We're going to replace the f of x with y. So we're working with y equals x plus 3. I'm going to create a table of values, but here's the thing. I'm not given any official domain. I'm picking my own. 0, 1, 2, 3, that works for me. You can use any numbers you want. You want to focus on the fact that this is a sample. So put the 0 in for x, and that gives you 3 for y. Put the 1 in for x, you get 4. Put the 2 in for x, you get 5. Put the 3 in for x, you get 6. But the difference between this one and the last one is that these are a sample of all the different values that can work for this function. So first of all, we're going to plot these points, 0, 3, 1, 4, 2, 5, 3, 6. Then we're going to draw a line through them to be able to include all the values that would actually work, not just these 4. So when we look at domain and range here, domain would be all the numbers to the right and to the left, and you can see that that goes on forever, so negative to positive infinity. And range would be how far up and down this graph goes, and that also goes forever. So the range would also be negative infinity to positive infinity. So that's it. Hope you learned something. Click like and subscribe. And if you're interested in the unit that goes along with this video, click the link below. Thanks for watching.